Hello engineers, welcome back. In the previous video, we got some introduction to time and space complexity. In the video before that, we looked into arrays and the basic operations that we can do on arrays. So in this video, we will continue to learn arrays. We will expand our knowledge a little bit using the two pointers technique. Okay, let's get started. So in this video, we're going to look at two pointers in arrays and we will see how it works. Okay. So far in arrays, we have seen these two things, forward pass and reverse pass. So just to recap, how did that look like? Let's say I have an array A and it has 5 elements, 1, 2, 3, 4, 5. Very simple. And if I wanted to print the array, I made use of a for loop. For int I equal to 0, I less than 5, I plus plus, and we have simply printed it, a of I. This was the forward pass, right? So if I wanted to print the array in a reverse order, print reverse array, what we'll do? We'll simply reverse the loop. We will start the loop at the end. Int I equals 4, I greater than equal to 0, I plus plus. And then we'll simply see out a of I. Okay, this was the reverse printing. So in both these cases, we have iterated over the array using a single pointer. This is not the pointer that is holding the address variable. This is pointer in the sense that it is pointing to one index in the array. Okay, so here the index was I. So whenever we moved I was starting here and we moved the I forward in this case. And in the second case, we placed the I here at index 4 and then we moved it in the reverse direction. So that's all we did so far. Very basic stuff. Now let's take it a little higher and let's see what happens if we can put two pointers to an array. Now this is our array. In the memory we have it like this, right? 1, 2, 3, 4 and 5. And we have indexes 0, 1, 2, 3 and 4. So far we have used array like in the forward direction we placed I at 0 and did this, and then we placed I at index 4 and did this. So what happens if we combine all this? What happens if we do all this? Let's say we put two indexes, one in the forward direction, let's call it I, one in the reverse direction, let's call it J. So these are two pointers in the opposite direction. So we are discussing this piece. So what happens now? I can move I in the forward direction, I can move J in the reverse direction, right? And I can do stuff with it. So what kind of stuff can I do? Let's take a simple example where we can use such a technique. Let's say my use case is, or my question is, reverse an array. So whenever we get a question, we try to first find the brute force method or the straightforward method without using any technique, how this can be achieved. So how would we achieve this? So if this is my array, a equal to 1, 2, 3, 4, 5. If I want to reverse this, I can simply ask for another array, b, which is empty, and I can put stuff in it, right? So let's say I want to reverse this array. What I can do? I can do a for loop, int I equal to 0, I less than 5, I plus plus. And for every element of I, I'll place it in the opposite direction of B. So if this is my A in the memory, 1, 2, 3, 4, 5, and this is my B, which is empty right now. So in both cases, the indexes are same, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So whatever is in index 0, I will place it in index 4. Okay, so now my index is in 0. I need to place this in index 4 of B array. So B of 4 will become A of 0. So how can we achieve this? How do we get 4 here? So we get 4 by saying index of 4 minus I. What is I? I is 0. 4 minus 0 is 0. And then I can simply do A of I. So we can remove this statement and let's see this. Let's trace this. So this is my I is starting at 0. And what is my LHS? LHS is B of 4 minus I. And 4 minus 0 becomes 0. So this is B of 4. And what is my RHS? A of I. My RHS is A of I. And that is A of 0. So what is in A of 0? A of 0 is having the value 1. So 1 is here. So 1 gets copied into B of 4. And now I will become 1. So this will become B of 4 minus 1. This will become 3. And this is A of 1. A of 1 has the number 2. 2 gets copied here. And so on. So we get 2 here. This is B of 2. And this becomes 3. We have 3 here. This becomes B of 3. And this becomes 4. And we have 4 here. B of 4. And this becomes 5. So 5 gets copied into B of 4 and we have achieved our result. We will simply return B. So what is this approach? So it is an approach where we are operating over the array in forward pass, like we are iterating over it in a forward pass. So what is the time and space complexity? So time complexity is 5 operations, right? Because we have passed it from left to right, we have done 5 operations. What is the space complexity? In this case, the space complexity is also 5 spaces. 5 spaces. If they were the array size was 10, we would have asked for 10 spaces and so on. So we have used additional space. In the traditional method, when we have used additional space. So now the question is, can we avoid this? Can we avoid this? So this is additional space. Oops, additional. Is there a way to avoid this? So let's see if we can use our 2-pointer technique to avoid this. So what I can do, I have this array 1 2 3 4 5. Now instead of doing a forward pass, I can place one pointer here I, and I can place one pointer here j. So what is happening when we are reversing? What is the desired result? Desired result is this: 5 4 4 3 2 1. So if we analyze this, what is happening? The first element is going to the last position, the second most element is going to the second last position, third element is remaining the same, fourth element is going to the second position from the left, and fifth position is coming to the first position. So this is what is reverse. So what can we do if we are placing 2 pointers? So I is here and j is here. If we just swap them, swap, so 5 comes here, 1 goes there, and then we move I forward, we move j in the backward direction. So I comes here, j comes here, we do a swap. So 2 goes here, 4 goes here, and then swap. And then I and j are here. And we are done. So let's see how this will work in code. Let's say I equal to 0 and j equal to 4. And let's do a loop. Now this time we cannot use for loop. We are not doing a forward pass or a reverse pass. So for making any loop, we need to first find the exit condition. When should the loop break? In our previous cases, we did forward pass. We know the length of the array. So whenever I is going beyond the length of the array, we come out of the loop. So we already know the exit condition. But for using 2 pointers, what can be the exit condition? So the exit condition is whenever I and j are together, whenever I and j are together, the next step, in the next step, I will go beyond j and j will go beyond I. So let me draw this clearly. 1, 2, 3, 4, 5, and at this point I and j are here after a couple of passes. Now the next step after this, when we do I a forward pass and j in the reverse direction, so I goes here and j goes here. In this case, I has crossed j. I has crossed j. So this has become j is in ahead of I. This is something we can call it as our exit condition, which means that we have successfully looked at every element in the array at this point of time. We have looked at every element in the array. Okay, so we can either do when I equal to j, we can come out of the loop, or when I is greater than j, we can come out of the line or loop. We can come out of the loop. Okay, so that will be our exit condition. So how do we do this? We can make use of a for loop. For loop. So until this condition is not met, we can continue in the loop. So how will this look like? While I less than j. While I less than j, I can do stuff in the loop. So I will keep going forward, j will keep coming backward. So how does this happen? For every pass, I will make I plus plus and j minus minus. So after every loop iteration, I'm taking I forward and taking j backward. Okay. And then whatever I want to do in the loop, I can do here. So this is the loop construct. This is my exit condition. Okay. So how will this exit condition be met? By doing the incrementing decrementing. Okay. So what do we do inside? We want to swap, right? So how do we swap? We can do swap like this. So let's take a temporary element where we can hold a of I, and then we change a of I to a of j, and then we do a of j equal to temp. Simple. This is swapping technique. So what is happening here? Let's see. So this is temp. Temp is having a of I. Let's say a of I is holding the value 1, and now we are having a and b here. So a is holding value 1, b is holding value 2. Now we want to do a swap. So we have copied a into temp so that we don't lose it, and now we can simply do b equal to a. Sorry, let's take the examples of I and j only so that it's not confusing. This is not a and b, this is I and j. I and j. So a of I is having 1, a of j is having 2. So now we have copied a of j into a of I. So now this is gone. Here we have 2. Now what do? We need to put 1 here. So we'll simply do this here and 1 will come here. So this is the swapping method. We simply had an extra temporary variable. Okay, and then we simply return a, our original array. So in what is the time complexity of this? Time complexity is again 5 operations. We have successfully done this in 5 operations. No problem. We have used the array once. We looked at every element only once because I was going forward, j was going backward, and once they met each other, we have stopped. So no problem. And what is the space complexity? We have not used any extra space, so 0 extra space. So we have not used any extra space. So this is good. So we have optimized our algorithm from this. We have optimized. We no longer need this additional space. So using the 2-pointer technique, we have achieved this. Okay. So let's try to write this in code and see how it works. Let's go to VS Code. So I created a new file called reverse.cpp. So let's do this. So let's say this is our array, and we have simple 5 elements, and let's call it 1 2 3 4 5. Now we want to reverse it, so we will take the help of 2 pointers. So let's call our first pointer, which is at the beginning of the array. Let's call our second pointer, which is at the end of the array. Right, now let's start our loop and create our exit condition. As long as I equal to j or I less than j, we can stay in the loop. And how will we come out of the loop? By doing I plus plus j minus minus at every pass. So this is my loop exit condition. Okay, now what do I want to do? I want to do a swap. So how do I do it? So let's take a temporary variable where we'll store either of the values. I can choose to do a of I, or I can choose to do a of j also. Either way, it's a temporary variable. It gets destroyed after each pass. Okay, now I've saved a of I in temp. Now let's remove a of I and put a of j in its place. Now a of j is successfully copied into a of I. Now let's copy whatever was there in a of I into a of j. So now this is a of j and this gets temp. So this way we are able to swap it. I think that's it. So let's check if this will work. So let's print it before and after. So how do we print? Let's do a forward pass and simply print. Int I equal to 0, I less than 5, I plus plus, and cout a of I, and let's call this before, and I can repeat this after reversing. After reverse. Okay, let's see how that works. Okay, so before 1 2 3 4 5 and after 5 4 3 2 1. So it is working perfectly. Okay, so that way we can use our two pointer technique to uh, optimize our solution. So we have used a brute force method where we were using extra space. Now we have optimized that to use no extra space. So we have optimized our solution using two pointers. So this opens up some opportunities, right? We have learned a new technique where we can use two pointers instead of one pointer and solves different kinds of solution. So this is in the opposite direction. Now we can also put the pointers to work in the same direction. So how does this work? So let's say again, let's say this is my array 1 2 3 4 5, and these are my indexes 0 1 2 3 4. So instead of putting I and j in the opposite direction, I can put I and j here only at the initial points, and I can make both of them go in the same direction, same forward direction. Okay, so let's take a fun example for this. Let's say we are building a race application, and we know the famous race between rabbit and tortoise, right? Rabbit and tortoise. So let's say we want to put them in a race. So they are both at the initial position. Instead of calling them I and j, let's call them R and T. So R and T go in the forward direction. So this is the race. So how will the race end? When they reach the end of the array, the race finishes. So this is the finish line. This is the finish line. Now, if rabbit and tortoise run at the same pace, they both will reach at the same time, right? If I keep doing R plus plus, T plus plus, they both will reach at the same time, and it will be a draw. Nobody is the winner. They are both equally fast. But as we know, rabbit is faster than tortoise, so we can optimize the pace at which these things go. So let's say I have a different variable that is saving how fast they go. So let's say tortoise pace is 1. It can only go one step at a time. And let's say my rabbit is twice as fast. A rabbit can go 2 times. So in this case, the rabbit will reach faster. So how does this application look like? So let's say I'm starting my two pointers at the initial position. R is 0 and T is 0. Both are at the initial starting line. Now what is my end condition? While we want both of them to finish the race. So while R less than 5, this is the end line, end finish line, or T less than 5. I think that's correct. R less than 5. As long as rabbit is still in race, we can continue in the loop. As long as tortoise is still in the race, we can continue. Okay, so this is the OR condition. As long as both of them are in the race will go on. So what are we doing inside? So we are moving the tortoise and rabbit forward. So how do we do it? Instead of doing it r plus plus t plus plus, now we will make use of their pace variables. So we can say r equal to r plus rabbit pace, t equal to t plus tortoise pace. Okay, so what is happening here? Let's take another variable to store who is the winner. Let's say our winner is tortoise or rabbit. So at this point there is no winner, and let's say this is a character variable. Here we will store either r or we will store t and see who is the winner. Okay, now as soon as we come inside the loop, we want to check whether the rabbit or tortoise have already reached the finish line. Okay, so how will we check that? If r is greater than or equal to 5, 5 is the finish line, then we will simply say winner equal to r. We'll have the same condition for tortoise. If t greater than equal to 5, winner equal to t, and that's it. So we simply return what do we return? We return winner, or we will print. Instead of return, we will simply print the winner. Okay, shall we do this in code and see how this goes? Let's see. So let's create a new file. Let's call it two pointers same direction. This is the example for two pointers in same direction. So let's create our function. Let's create our base template because we want to print. Okay, let's create our main function and we are good to go. So let's call our array int a of 5 equal to 1 2 3 4 5, and now we have, let's call our rabbit and place the rabbit at the starting line. Let's call our tortoise. Let's place the tortoise at the starting line, and let's set their individual paces. Pace of rabbit is 2. It can go twice as fast. Pace of tortoise is just 1. Okay, now we can start the race. So what, anytime when we are doing a loop, let's first create the exit condition, otherwise we might fall into infinite loop trap. So what will be the exit condition? While r is less than 5 or t is less than 5. So as long as r and t are still less than 5, we are in the race. And how do they move forward? They move forward as per their pace. So r equal to r plus rabbit pace, t equal to t plus tortoise pace. Let's call this tortoise pace. Okay, so this is the race. So how will we declare the winner? Let's call a character variable, and that is winner. So how will we find the winner? If rabbit has crossed the finish line, if rabbit has crossed the finish line, then winner will be R. And if tortoise has crossed the finish line, then winner will be tortoise. And finally, let's print the winner. Cout winner is winner, and line, and done. So let's clear the output and let's see if we have done everything right. So I think we did right. Winner is rabbit. So let's trace this, what we have done. So we've initialized rabbit and tortoise at the first index, and we have set their paces. Tortoise is going at pace of 1, rabbit is going at pace of 2, and while rabbit or tortoise are still in the loop, the race will continue. And if rabbit has crossed the finish line, 5 is the finish line, because not this 5 is the length of the array. The length of the array is 5. If they have crossed the length of the array, which means they have crossed the finish line and they have uh, finished the race. So if rabbit has done that, winner will be rabbit. If tortoise has done it, winner will be tortoise, and we are incrementing them as per their pace. Okay, let's change the paces and see if tortoise can win. Now tortoise is twice as fast, hypothetically, and let's see if our logic is working. Now winner is T. So now tortoise has won. Okay, so although this is a trivial example, this is to help you understand the different techniques that can be used with arrays. Okay, so we have seen how to do it in opposite direction, we have seen how to do it in same direction. So these are like extra techniques to play with arrays. So we are able to do forward pass, now we are able to do reverse pass, we are able to put 2 pointers in opposite direction, move them together, we are able to do same pointers in the same move them in the same direction. Okay, we could also put them in the middle of the array and move them in the opposite direction, and things like that. So the opportunities open up, and when we are looking at different types of questions, our brain can, think in such directions. If we put 2 pointers, can we achieve the solution? If we put 3 pointers, can we achieve the solution? There's nothing stopping us from putting 3 pointers, right? But it gets slightly complex to trace out 3 pointers, but usually 2 pointers are a good start. Okay, so that's it for this video, guys. I hope you understood the 2 pointer concept. In the next video, we will solve an actual lead code question on 2 pointers, so stay tuned for that. So in this video, if you have any question, please do ask me, and thank you so much for watching. I will see you in the next one. Cheers.